Hello everyone, welcome to Altium Academy. I'm your host, Zach Peterson. Today we're going to be talking about something that is sometimes done in PCB manufacturing and which I've seen pop up multiple times on social media, and that is copper thieving. Now, I've seen this come up on LinkedIn, on Reddit, and in one of our 1-minute design review submissions recently, so you know I had to make a video about it. We're gonna get into what is copper thieving, why is it used, and how do you actually create copper thieving squares inside Altium. Let's go ahead and jump in and get started. Now, the topic for today's video is copper thieving, and this topic came to my attention while doing what I like to do these days, which is browse Reddit instead of doom scrolling on LinkedIn. Let's go ahead and take a look at that Reddit post. Dry Animator 9357 writes, while browsing a PCB online, I found an unusual polygon fill pattern. Does anyone know how to create one similar to this? And here you can see a bunch of squares that look like they are floating or disconnected, and they are in the middle of what looks like to be a bunch of component pads. So you can see all the different component pads here. You can actually see net names right here. You can see the very clear indicator of vias, and then you see all of these pads scattered around this PCB. Now, what is this? Well, this type of square hatched pattern is called copper thieving, as indicated right here by Toy Builder. Toy Builder writes, this is copper thieving, usually done by fabricators per fabrication notes. Chillboy72 adds a little bit of context here and writes, they're added by the PCB fabricator. On the outer layers, it's called copper thieving. On the inner layers, it's called copper balancing. They help maintain uniform copper distribution for a more consistent manufacturing process. And the last comment I want to look at is Patient Gas 883. Patient Gas writes, copper thieving adds dummy copper to empty PCB areas to make plating and etching more uniform, improve copper balance, and reduce board warping. It should be kept away from RF impedance controlled, high voltage, and flex bend areas. Now, this post and these comments got me really curious, and I decided to look into this a little bit deeper and see if there was any justification for all this and what manufacturers actually say about copper thieving, as well as what some of the experts say about copper thieving. I also did a little bit of a deep dive into the scholarly literature to see if there is any real justification for any of the things that have been said about copper thieving in this Reddit post. So what we're going to do first is take a look at one of the articles posted on the Altium blog. Here we have an article by Kellenak. It is titled, What is Thieving in PCBs and Why is it Done? We have another image of thieving in this hero image. These are actually circular patterns. So it looks like you can use pretty much any type of pattern you want, whether it's a diamond pattern, square pattern, circular pattern. Here we have a paragraph that describes what happens if you don't add copper thieving to the outer layers of a PCB. If copper thieving has not been added to the outer layers of a PCB that have uneven distribution of features to be plated, such as controlled impedance traces, holes for press fit connectors, and component mounting pads, the features that are isolated will plate up with far more copper than those that are more densely packed. Now, this states what we are trying to plate up during the plating process, but not why we have an issue with non-uniformity of the deposited plating. You'll see here there is a section on pattern plating. So Kella writes, pattern plating is a process where copper is plated only on the features that will remain behind after the outer layers are finally etched. Usually those features are all of the plated through holes, traces, and component mounting pads on the outer layers. Again, we're talking about plating up the plated through holes, and that requires also applying plating to the outer layers. The problem with pattern plating is that if the features on the outside layers are not evenly distributed across the surface, then the plating currents will also not be evenly distributed, and some features, such as via holes and connector holes, will plate less heavily or uniformly than others that are spaced farther apart. Now, when there is a need for very uniform plating, such as in the holes of a press fit connector, something must be done to spread out the current evenly across the entire surface, and this is where copper thieving is used. So what Kella-Nack brings up in this article is the issue with non-uniformity of the plating distribution. That is one of the things that was mentioned in the Reddit post, but there are other issues mentioned in the Reddit post that she didn't mention. One of those is warpage, another one is etch uniformity, and then the third one is even copper distribution. So let's take a look at what some PCB manufacturers have to say about copper thieving. First, we have a post here from FS Technologies. FS Technology is a Chinese PCB manufacturer. Here they have a post on LinkedIn where they go into copper thieving, and they talk about this only from the perspective of copper balance. And here they don't actually mention anything about the plating uniformity. You can see here the only thing they talk about is copper balance and why it matters. Now they do mention uneven copper plating thickness as part of copper balance, but they don't say anything about how this affects the plating process. So it might bring into doubt why the plating process is actually impacted by the presence of thieving squares. Now, if we go over to JLCPCB's website, you'll actually see that they have a really great article here all about copper thieving. They actually have one of the images that was posted in the FS Technology post, but they also mention all of the points that were brought up in one of the comments in the Reddit post. You can see here that they do mention warped PCBs. Here they mention etching uniformity. And then if you scroll down here, you'll see that they do mention electroplating uniformity, and they have this graphic here that they've generated that shows the current density lines and basically trying to show what can happen when you have non-uniform current density. So we looked at what an industry expert and some companies in the industry have to say about the use of copper thieving, but what does the research literature say? Well, I found one article from IEEE, and you can see it here on screen. This is titled, "A Study on the Effectiveness of Dummy Pattern Design Existence in Multi-Layer PBGA Applications." So here when they say dummy pattern, they're actually referring to something like copper thieving. And you can see what they mean when they say dummy pattern if you just scroll down here to figure 1. They've used these copper stripe features to design their dummy pattern in a PBGA substrate. So why do PBGA substrates matter? How does it relate to the printed circuit boards? Well, these are basically made from FR4 materials, and they are plated up with very similar processes used in printed circuit board fabrication. So this is a useful reference that tells us what can happen in these plating processes on organic materials. What are the conclusions of this study? Well, I don't have time to go through everything in this study, but if we just scroll down here and we look at the conclusions, in the very last sentence of the conclusion, they state that they found that the dummy pattern will reduce total package warpage. So this is one reference that does help justify the use of a dummy copper pattern or copper thieving in reducing warpage in substrates that have been plated up with copper. And that could be a PCB substrate or an integrated circuit substrate. Now, I'm not surprised that this was done in the context of integrated circuit substrates, but you would expect reasonably similar results with PCBs because they are used with similar materials, similar stack-up processes, and similar plating processes. Next, I also found an article in the Journal of the Electrochemical Society, and you can see I have it here on screen on ResearchGate. And here in this study, they actually looked at what happens with plating processes on full-size printed circuit board panels, as you can see here right in the abstract. Now specifically what they looked at was through-hole patterns on a printed circuit board and how that impacts the non-uniformity of the plating thickness, or in this case the boundary layer thickness during electroplating. Now here, if we scroll down to their conclusions, you'll see a little bit more what they have to say about the boundary layer thickness. Here they present a model that does predict variation in that boundary layer thickness for through-hole arrays. However, when you get to lower diameter vias, they show smaller variation in that boundary layer thickness. So apparently the non-uniformity in plating doesn't just depend on the distribution of vias, it also depends on the diameter of those vias. So if you dig deep enough, it seems that you will find justification for the use of copper thieving in all of its various benefits that are mentioned throughout the internet. So that then begs the question, if you're a designer and you are finalizing your printed circuit board, should you put copper thieving on the outer or inner layers of your PCB? Well, at the end of the day, this is normally a recommendation from your manufacturer. They're going to be the ones that can tell you whether or not you're going to have an issue with plating uniformity. Now, as far as producing prototypes, I've never had a manufacturer come to me and tell me that I need to use thieving squares in my design files, and I've never seen a manufacturer put the thieving squares into my design or ask me if they could put the thieving squares into my design so that they could ensure plating uniformity in that build. Now, at high volume, it's a little bit different. At high volume, you're going to have a quality control team that's going to look at boards coming off the line. They're going to put test panels through a test process. They're going to actually take measurements and check whether or not you are getting uniform plating everywhere on the board. In that case, they're going to be the ones to tell you whether or not copper thieving needs to be added, or maybe copper fill needs to be added as a proxy in order to make sure that you have uniform plating everywhere. So I would say in prototyping, it probably doesn't matter at all, and you can just submit your design without the thieving squares. But at high volume, you really need to work with the manufacturer to ensure that their process is going to give you high yield and the plating uniformity that you need everywhere in your board. Now, if you did want to add in thieving squares into your design, you can actually do that inside of Altium Designer. So let's go ahead and jump in and check it out. So here I have a blank PCB inside of Altium Designer, and I'm going to show you how to create some thieving patterns inside Altium Designer just using the polygon tools. So here I'm just going to draw out a polygon. I'm just going to make a very simple square, and I'm going to leave this assigned to no net. And that is very important. You don't want to attach this to any net or assign it to any net, because then you're going to have a bunch of floating copper that then wants to get assigned to a net. So it's going to give you an unrouted net error. Now, once I create this square, what I'm going to want to do is make a copy of it. Then I'm going to take the square as is, and I'm going to make it a hatched square. And when I hit re-pour, you'll see here that it puts in some hatching lines. Now, what you can do here is you can use the 90-degree hatch, you can use the 45-degree hatch if you want to create a diamond pattern. Here, let's just use the 45-degree hatch for fun. So here you can see we have a 45-degree hatch pattern. It has some holes in it. Then what I'm going to do is I'm going to paste that original polygon right here back on top of that hatched polygon. Now you notice here that if I re-pour all the polygons, the second polygon disappears. Why is that? Well, we need to change some settings on that pasted polygon in order to get it to appear as a proper thieving pattern. So the first thing I'm going to do is I'm going to take this hatched polygon and I'm going to shelve it. Then what I'm going to do is I'm going to select this polygon, and the first thing that I need to do is I need to click Remove Islands. I want to make sure that that is disabled. I also want to make sure that I don't pour over same net objects. Then what I can do, go back to the polygon manager, and I want to switch these. I want to unshelve the original hatched polygon and shelve my new polygon. So now we're looking at the hatched polygon. Now there's something important that I need to do here in this hatched polygon. One of the reasons it causes that pasted polygon to totally disappear is because the clearance constraint in the design rules is basically eliminating all that copper in these openings in the hatched polygon. So what I need to do is I need to make my track width pretty small, maybe something like 5 mils, and then I need to make my grid size something reasonably large, maybe something like 50 mils. And then I can go ahead and re-pour this. Also, we want to make sure that we don't pour over same net objects. Then what we can do is we can go ahead and restore all of our polygons. We'll then do TGA to re-pour all the polygons. And there you go. You now see that you have 2 polygons here. One is our original hatched polygon, which is right here. I can then go up and shelve this, and there we go. We're left over with our copper thieving pattern. Now just note, if I take this copper pour that has this thieving pattern and I re-pour it with that hatched pattern still shelved, you'll notice that it totally fills in. So if you want to re-pour that thieving pattern, you need to make sure that you restore the original hatched pattern. Then when you re-pour all the polygons, you'll see here that it restores both the hatch pattern and the thieving pattern. So that's how you do copper thieving inside of Altium Designer. Just make sure you watch those clearance rules and you set the feature sizes on the hatched polygon correctly to ensure that you can fit those thieving squares inside the hatch pattern. Thanks for watching this video, everybody. Make sure to hit the like button, hit the subscribe button, leave your comments and questions in the comments section, and last but not least, don't forget to call your fabricator about your thieving patterns, folks. We'll see you next time.